Okay. All right. Thank you very much. Hi, everybody. Thanks for coming today. We're going to talk about how to scale your cluster. First, I'm Patrick Chanezon. I'm a cloud advocate at Microsoft. And initially, we were supposed to do a duo with my colleague, Scott Coulton, who's a cloud advocate at Microsoft as well. But he's based in Australia. There are some fires around Sydney, so he had to stay home. So he won't be there. But I'll show you his code and his demo. All right. So we're going to talk about several aspects of scaling. One is the horizontal pod autoscaler. Then we'll talk about how to scale compute in your cluster in general. And then we'll talk about scaling to zero, which is super useful when you want to do a serverless type scenario on top of Kubernetes. And then I'll show you a demo that wraps it all up together. So first, the horizontal pod autoscaler. Kubernetes is an orchestrator for containers. When you launch containers, you want sometimes to scale your app in an automatic way, and the horizontal pod autoscaler is there for you. It helps you automatically scale the number of pods in a replication controller or a replica set based on looking at CPU utilization or different metrics out there. So it's a component of Kubernetes. It's looking at that metric server, and based on the metrics that are coming back, and depending on how you program it, you can do, it will manage a deployment and scale the pods automatically. Okay, so that's the horizontal pod autoscaler. Now, what happens when you schedule some pods on your cluster and the pods, there's no more compute resources? If you're in the cloud, there are several ways of doing that. There are two options. One of them is through virtual machines, adding some compute nodes to your Kubernetes cluster. And if you're in the cloud, you don't need to go roll a new physical server and plug it and install all that stuff and then add it to the cluster. You can provision VMs in a pretty automated way. The other option that's getting more and more popular is called the Virtual Kubelet. In Kubernetes, the component that is scheduling your containers is called the Kubelet, and that's a piece of software that's running on the physical node, and that's leveraging some primitives from the operating system in order to create containers or these isolated units of compute. So typically, it's doing that using primitives from the Linux kernel. Hey, good to see you. Ben Corey is here. So primitives from the Linux kernel or from the Windows kernel. Sometimes it can use things like a VMware isolation primitives to create these containers. What the virtual kubelet is an implementation of the kubelet that responds to the same API, but creates virtual machines in different cloud providers, or leverages the cloud providers' APIs to create these units of compute. So to scale your compute with virtual machine, this is for many cloud providers, there are some implementations of what is called the cluster autoscaler. When you schedule your pod, if there's no more capacity, you can configure the cluster autoscaler to automatically go add some new nodes to your cluster in Azure, for example. That would be the Azure implementation. And then once the node has been added to the cluster automatically, the pods can be scheduled on that node. So that's a pretty simple way of doing that. There's a high level of granularity there where you provision a whole new machine potentially for just one more container that's coming in. And so the other option of using the virtual kubelet gives you more granularity there. So most clouds allow you to scale the machines up when there's some load, or scale the machine back down to a specific number. Now let's talk about the virtual kubelet there. It really removes the dependency on servers for worker nodes. When Kubernetes was designed, it was really designed to create containers based on the Docker runtime that was leveraging Linux primitives to isolate the processes. Then the Windows runtime Windows support was added in Docker, and so Kubernetes is still using that to schedule containers on Windows nodes. With a virtual kubelet, you just get rid of the dependency on server nodes, and you're just leveraging your cloud provider's APIs to provision virtual machines that correspond to one container. And so it allows for, it's very good for scenarios where you have burstable workloads. For example, when you have workloads that depend on the length of a queue, you can leverage your cloud provider's capacity there instead of having to do capacity planning for the number of nodes that you would need there. So the way the virtual kubelet works is it's like the kubelet, but it's leveraging APIs that are specific to each cloud provider in order to schedule your workloads. And so when you add the virtual kubelet to your cluster, you'll be able to specify that you want to use that type of node or that type of a container for the container that you schedule. And so the implementation that I'll show you here is based on ACI, Azure Container Instance, which is the technology on Azure, and that's what that looks like. Where you can really burst and create all these VMs automatically, and there will be one pod per VM. Virtual Kubelet is an open source project. There are many other implementations for Alibaba, AWS, and others. And it supports Linux containers, Windows containers, and nodes with GPUs. So you specify that in the characteristics of your deployment for your pod. So in order to deploy an application to the virtual kubelet, once you have configured your cluster to implement the virtual kubelet and configured the virtual kubelet to be able to leverage that, it looks something like that with a node selector, where you specify the OS and the type will be virtual kubelet, and then you can add some tolerations. And the tolerations here is that here when I'm scheduling my pod, I want to make sure that the azure.com/ACI provider for the virtual kubelet is provisioned on the cluster. So you can specify these with tolerations. Now scaling to 0, there's a project by Microsoft that's an open source project, and there are a lot of other people participating in it. That's called KEDA, the Kubernetes Event-Driven Autoscaling. And so KEDA is an open source project that you can run in your Kubernetes cluster. It can run in the cloud or at the edge. And it integrates, it's one of these solutions that helps you build your own serverless implementation on your own, on top of Kubernetes. So there are lots of projects out there doing that. One of the characteristics of KEDA is that it is very, I'd say, Kubernetes Centric, where it's leveraging what Kubernetes has, for example, the horizontal pod autoscaler, and there's no external dependencies like a specific service mesh or things like that in order to use KEDA. KEDA 1.0 was announced yesterday, so you can go see the blog post. What it means is that it's ready for production, so you can start kicking the tires with it and see how it works. So how KEDA works? So KEDA performs two roles in Kubernetes. First, it's an agent to activate and deactivate a deployment, scale it from or to 0 when there are no events. So KEDA really allows you to implement these serverless architectures where you have a compute that is triggered by events, and that can scale up automatically based on the number of events in the queue, or scale down to 0, which is very good from a cost perspective. So KEDA is the component that is activating and deactivating your deployment based on what's in that queue. And then the second aspect is that KEDA acts as a metric server for Kubernetes. So it exposes some of these events data that you can use to make decisions about whether you want to schedule more containers, things like queue length or stream lag, and then you'll be able to decide based on that. And that is driving the pod autoscaler to scale up and down your deployments. So KEDA is leveraging the horizontal pod autoscaler behind the scenes. So that's, I would say, one of the big differences with other serverless type of projects who are implementing their own for this. This is using the native Kubernetes primitives that are in there. And then, so this allows a rich integration with the events themselves. And so you can do things like completing or abandoning queue messages. And so that's the KEDA architecture. It's a server that runs in a pod in a service in your Kubernetes cluster. You just install it with Helm or with a YAML deployment, but it's pretty simple to install. And then it's working in conjunction with the Kubernetes pod autoscaler in order to create your deployments and in order to scale your deployments. So there's a rich library of event sources that KEDA implements out of the box. Things like Kafka, RabbitMQ, Azure Storage Queues, Azure Service Bus Queues, AWS SQS, and Prometheus. And there's constantly new ones who are added in the open source project. So you can use that with lots of different type of event source. Okay, so now demo time. I think I'll do a little bit of explanation before doing the demo so that you have a better understanding of how it works. So first, you need to install KEDA. I've done that already in the cluster here, but typically you can install it with Helm like this by adding the KEDA core repo in there and doing a Helm install with it. And you can pass a few parameters in there. In the test that we're going to do here, in the demo, I'm going to show you an AKS, an Azure Kubernetes Service cluster that is configured with the Virtual Kubelet to use ACI, and that has KEDA installed. And we're going to scale our application based on RabbitMQ queue. So we have installed RabbitMQ in that cluster. And then we're going to deploy a consumer who's going to consume the RabbitMQ events. And so when you're deploying the consumer here, you can see that I have the node selector that tells me that that consumer, that container that I deploy as a RabbitMQ consumer, that's going to consume events from Rabbit. I want that to be deployed with ACI. And so that's the snippet of text that you saw in the YAML before. And then we can deploy our scaled object. And so here you can see that KEDA defines an API, keda.kubernetes.io. And it defines a new kind that's called a scale object. And in there, we can specify things like polling interval, cooldown period, max replica count. And we can pass some parameters like which Rabbit server should I get my events from. And then once I have deployed all that and I have configured all this, what I can do is start to deploy a publisher. So that's a simple pod that's going to send some events inside of Rabbit. And then I'm going to watch KEDA look at that RabbitMQ queue. I'm going to watch the pod, the horizontal pod autoscaler create all these ACI instances based on the load that it's receiving from the RabbitMQ queue filling up, and then I'll just kill the event producer, and you'll see that KEDA is going to scale down the number of ACI instances. So that's what I'm going to show. And then, so there's an additional kind of fun thing that you can do with this, which is there's lots of components to install with it. Microsoft and Docker had created a spec a few months ago that's advancing a lot and that's getting more and more useful. That's called CNAB, the Cloud Native Application Bundle. So that's a specification. There are two implementations. One of them is Docker apps. So Docker implements CNAB for Docker apps. The other implementation by Microsoft is called Porter. And Scott has created a whole, like that, all the containers involved in that demo, like installing KEDA, installing RabbitMQ, the producer, the consumer, all that wrapped together inside of a CNAB bundle, and there are some instructions there for how to do that. Okay, so let's now do the demo. So just going to go there. Okay. So I'm just going to clear my screen. So is it big enough? Can you read correctly? Yes. Okay. Cool. So first, I'm going to do a kubectl get nodes, just to show you that I'm using a Kubernetes cluster that's in. I don't remember which region it is in, but it's an AKS cluster that has been configured with KEDA in it. So let's take a look at what KEDA looks like. If I do kubectl get namespaces, let's see the namespaces we have in that cluster. Oh, it's pretty slow. So you can see I have a few namespaces in there. That must be a demo. And then we have KEDA there. So if I do kubectl, I never know if it's kubectl or kubectl. I know there are two camps there. -ns KEDA get all. So, sorry. Kubectl get all. -ns KEDA. Dash namespace maybe, or -n. Yeah. Yeah. Okay, so let's take a look at what's in that namespace. So here you see we have the KEDA pod that's running in there, and we have a service, and this is where the KEDA metrics server is going to be exposed. So then I'm going to go. I'm going to make that one bigger. Clear. And here I'm going to do a kubectl get horizontal pod autoscaler to look at what's in the autoscaler right now. And there. So that's what I installed there. And here I'm just going to take a look at the pods. So clear. I'm going to do a wait on the pods to look at the pods that are scheduled in that Kubernetes cluster. So here I have just one for RabbitMQ for now, and it's in watch mode, so I'm going to see them coming in. And then that's the horizontal pod autoscaler. So now what I can do here is I'm going to deploy the producer of events. So here, this is the, so that's the delete command. So here I'm going to do, I'm going to kubectl apply this job there that has a container that's the RabbitMQ client. I'm going to give it to it the address of the RabbitMQ service that is in my cluster. And what that client does is that it's just putting a bunch of events in the RabbitMQ queue. So I'm just going to deploy that. Oh, actually, let me. I'll just paste it from the docs here. So all these instructions that I'm showing, they're on a GitHub repo so that you can reproduce that at home, and I'll tweet about where the code is after the talk, and you can find all these instructions as well as the sample code in the deck. So I'm going to do that kube apply. Okay. So it has created a batch job with a RabbitMQ client who's going to add a bunch of events in Rabbit. So now let's take a look at here. So on the horizontal pod autoscaler, I don't have anything yet. But here, I start to have some interesting things. So here I have a bunch of RabbitMQ consumers, boom. So lots of them are pending. Some of them are creating. So you can see that there's lots of consumers that are, and so what happens behind the scenes is that once I have done that, once I have launched the producer of events, it's loading RabbitMQ with a bunch of events. Then KEDA is listening to that RabbitMQ queue and using the horizontal pod autoscaler to tell it, hey, we need more of this deployment, and that's what the pod autoscaler is just adding more of these pods to the deployment. And these pods, as you remember, they were specified as ACI. So these are virtual node ACI Linux in there in terms of types. I think I have limited it to 30, not to grow my Azure build too much. Let's take a look. Here we can see some of the metrics that are coming to say, hey, we have 1 replica, we have 4, we have 8, and boom, we reach the 30 max here. And here you have things like the number of average time that it takes to do them. So now what I'm going to do is I'm going to delete that deployment in order to show that KEDA is going to scale down to 0 by itself, so I don't have anything to do there. So I'm just I delete that pod, and in there I should start seeing some interesting things in the HPA, where the horizontal pod autoscaler is going to notice that so KEDA is going to tell it that there's no more events in there, that we don't need as many of these containers, and you can see they're all terminating in there. Boom, boom, boom. So it's scaling down my deployment back to 0 because there's no more events to consume in there. So that's the demo, and I think we have. Yes. Yeah, play from current slide. Yeah, so that's the demo. You can find the code on the demo either at this URL or as another from. It's part of that demo is part of a whole set of learning content that the cloud advocacy team at Microsoft that we build for a series of events that we're doing around the world called Ignite the Tour. And all our learning paths for Ignite the Tour are online. I'm going to actually, I can show you the link to it directly in my browser. And Scott has a version of that that is using CNAB and Porter if you want to go more on the cutting edge side. Okay. Okay, so that's it for the presentation and the demo. I'll tweet the link to the demo when that presentation is finished. To summarize, what I presented today is different ways to scale your workloads with Kubernetes. One of them is to use the horizontal pod autoscaler. Then in order to scale the compute, you can use either the cluster autoscaler or the virtual kubelet that's going to create pods using all your cloud as a resource. And then I talked about this open source project called KEDA that has event adapters for a whole series of events that lets you scale your compute or your specific applications down to 0 and auto-scale them up. And KEDA works really well in conjunction with Virtual Kubelet. And I think I'm nearly on time, so that's it for now. Do you have, are there any questions, or do some of you have tried these technologies before, or are there some specific use cases that you think would be useful for that? Yes?
How far can you scale it with KEDA?
So the question is, how far can you scale it with KEDA? And the answer is, it depends on your provider. So here I have set up KEDA to go between 0 and 30 using an ACI implementation. So there are some limits to, I actually don't know from the top of my head what the limit for ACI is in a specific region, but the limit becomes the limit of your provider implementation. Yes?
So if it cause any restriction in KEDA and HPA both we try to scale up or?
So the question, as I understand it, is can they be a kind of race condition where both HPA and KEDA are going to try to scale the same workloads? I guess in that case, it depends on how you have configured your workloads. You can deploy it by asking the horizontal pod autoscaler to take care of it. Then if you're using KEDA, you're configuring, you're putting some data in there to say, hey, I want this deployment to be managed by KEDA. So I guess you want to be careful about your deployment to target to one or the other. Yes?
Is there work to merge Knative?
So that's a good question. Is there work to merge KEDA with Knative? I don't know. I don't know the answer to that. I guess you would have to go ask the KEDA team. Some of the team members, I think, are at the Microsoft booth this week. Or else, just ping me on Twitter with a question, and I'll try to find the answer for you. One of the things that I see there is that Knative has a lot of components in there. I'm pretty sure that parts of what KEDA provides must be implemented in a different way in there. So I don't know what the... KEDA is a much smaller system that is very integrated with Kubernetes and doesn't need any additional things like Istio, or you can use it with any service mesh that you want there. So I'd say it's a slightly different design philosophy than Knative. Oops. And I think, yes, one more question maybe? So what is the startup time for these workloads? Oh, for the virtual kubelet. What is the startup time for containers created with a virtual kubelet? The answer is it depends. It depends on your provider. So for ACI, I'm pretty sure we must have that in the documentation. I don't know it from the top of my mind. That said, I don't know if you saw the demo. Yeah, or you can try it at home. So is there a cold startup time like Lambda for ACI? I don't know. That's it. I'll be outside of the room if you have any additional questions. And don't hesitate to ping me on Twitter. And I will share this deck later tonight. And you can find the code on GitHub. Thanks.